What's happening, dogs? Mr. Allen here with some evaluation of trig functions using our half angle formulas you see up there. Now for this one, we got cosine of theta is equal to 3 over 5, and theta is between 3 pi over 2 and 2 pi, meaning it's in the fourth quadrant. Then we're asked to find the sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. Now, we've seen the start of a problem like this before, right? We're going to start this problem the same way. We're going to sketch a triangle in the fourth quadrant here to help us solve this whole thing. We're just using new, fun, dope formulas here, all right? So let's sketch it up. I'm going to go all the way over here to sketch our triangle. It's in the fourth quadrant, right? So it's somewhere down here. Beautiful. My adjacent side is going to be 3, and my hypotenuse is 5. Well, my man Pythag can help us get that third side there. It's a 3, 4, 5 triangle, but it's going down, yelling timber, so it's a negative 4 for that one. And now I can use this triangle to figure all my other stuff out. Okay, I can get my sine and my cosine from that triangle. But there's one more piece to the puzzle that I like to figure out right now before I forget, and it deals with the plus or minus you see in front of the sine and cosine half angle formulas. Well, if I were to take this domain restriction here for theta, but I want to figure out my restriction for theta over 2, basically I'm trying to figure out the location, what quadrant am I in for theta over 2, I'd have to divide this by 2. But whatever I do to that, I got to do to everything else. So now my new restriction here becomes, and I'll jot it down right over here, it becomes 3 pi over 4 is less than theta over 2 is less than pi. So I'm between 3/4 pi and a full pi. Well, where is 3/4 pi to full pi? Well, full pi is right here, right? This is half pi. This is full pi. This is 3/4 pi. So basically, I'm somewhere in this range right here. This is where I'm chilling for my theta over 2 for this one. So I'm in the second quadrant, right? And in my second quadrant, my sine is going to be positive, but my cosine is going to be negative, okay? So I got to watch out for that in my final answers here. Okay, so sine's positive, cosine's negative. So we'll come back to that in a moment here. But let's get it going. Let's get some sine going. Let's get sine happening. I'm going to go with, we'll go green. We'll go green for sine. All right, so sine of theta over 2. Sine theta over 2 equals, we know it's going to be positive, right? We just decided that. It's in the second quadrant. Sine is positive in the second quadrant. We're going to have a square root of 1 minus cosine of theta. Well, I know cosine of theta is 3 over 5. There we go. 3 over 5 all over 2. Just 2. Okay. So now what do I need to do to simplify this thing and get this all worked out? Well, if I multiply by let's see here, 5, right? If I multiply the numerator by 5, it get rid of this fraction and make that a 5. But whatever I do to my numerator, I got to do to my denominator. So we're going to multiply by 5 over 5, which is like multiplying by 1. Which doesn't change anything, thus it's equivalent and totally mathematical legal. You won't see me haul the way to math jail when I multiply by 5 over 5, because that's legal. Okay, let's continue here. Now I've got square root of 5 minus 3, right, because this 5 and that 5 cancel, but this 5 multiplies that 1, all over 10. And now we have 5 minus 3, that's 2. So we get, let's see here, square root of 2 over 10, which is the square root of 1/5. Now, square root of 1/5 is just, 1 over the square root of 5, but in math land, we can't leave it like that. We have to rationalize our denominator because it apparently looks better. No, it's lame. I don't like it. I want to change it, okay? I got rants in all my videos about rationalizing the denominator these days, and it seems like a waste of time, you know? 1 times root 5 is root 5. And that's just 5. Does this really look better? Does root 5 over 5 look better than 1 over root 5? I didn't think so. But hey, that's what we got to do. That's what College Board does. That's what everybody does. We just follow blindly. Oh, I'm going to rationalize the denominator. Let's end that, okay? Band with me. Put it in the comments. You're like, I'm in, bro. I'm in. Let's stop rationalizing the denominator. For now, though, we just have to keep doing it. Otherwise, we'll get the answer wrong. Okay. So done with that one. All right. I'll put a little white line here. Separate some work. Boom. See if we can fit this all here. All right. Next one. We got, we'll go orange on this one. No, I'm going to go pink. No, orange. Okay. Cosine this time, which we said was going to be negative because it's in the second quadrant and cosine's negative there. So Make sure you remind me, okay? You guys remind me that it's negative. So we got cosine of theta over 2. So cosine of theta over 2. That's going to equal negative, there we go, now I won't forget, 1 plus cosine of theta, which we know is 3 over 5. Super convenient. All over 2. And now the same kind of process is going to occur here, right? I'm going to multiply this one by 5 over 5. So you go 5 times 1, so equals, back up over here. We got negative in front. 5 plus 3 over 10. So that equals negative. We got 8 over 10. That simplifies. We get negative, was that 4 over 5? What's the square root of 4? It's 2. So negative 2 over root 5. But I can't leave it like that. I have to rationalize. Root 5 over root 5. And our final answer will be negative 2 root 5 over 5. Because that looks better than negative 2 over root 5. We got to do a little bit of a screaming match. Not really. But we were getting upset with each other in the math department. You know, a few of us were we were going at it, man. You know, we almost went fist to cuffs, if you will. Right? You almost started throwing hands over rationalizing the denominator, man. I mean, we get passionate about these things, okay? And I think we should get rid of that. But hey, man, we got to keep going with it. Maybe one day, you'll be like, bro, we used to do that. I'm watching Mr. Allen's video here 3 years in the future, and we stopped doing that. Now that's the better answer, right? But for now, we'll just follow them blindly. Just keep doing it. Okay, last one. Tangent of theta over 2. I'm going to go with neon. Neon yellow. It looks very similar to green, but it is different, I swear. Okay, I have 2 of them, see? But they look really similar. Tangent of theta over 2. Tangent theta over 2. Now, this formula is actually nice. There's no square root. There's no like deciding positive, negative, right? It just works itself out, and that's just kind of wonderful. Okay, so we got 1 minus cosine of theta is 3 over 5. I haven't had to really do anything with this triangle yet until now. Sine of theta is negative 4 over 5. Negative 4 over 5. Opposite over hypotenuse. I'm going to multiply by my reciprocal. Yes, official notation of multiplying by the reciprocal of negative 5/4. And now what we have here is negative 5/4 times 1 is negative 5/4. And then we have negative, I'm gonna write this part out, minus, and then it's 3 over 5 times negative 5/4. I don't want to screw that up, right? This is canceling. The negative becomes positive. So now I have, see here, negative 5 over 4. We're running out of room. We got positive plus 3/4 equals, what is that? Negative 2 over 4, negative 1/2. Dude, that's really nice. That's fantastic. We did that right? I think we did that right. We'll find out later. All right. Negative 1/2. That's awesome. Wonderful, fantastic. And it fit. It fit. It just fit. My circle's a little bit off right there. But hey, we got the full answer. There we go, guys. All right. So, got to be careful with your numbers. Find out what quadrant the half angle is in. Other than that, dude, a little bit of Pythag. We can throw any of them at you. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are the common ones that'll help you out because all this stuff is going to be non-calculator when you're taking that test. I know fractions, square roots, rationalizing. Oh, great stuff. All right, except for the rationalizing. I don't like that. Anyways, have a great day, guys, and thanks for watching.